All right, guys, it's time to start a new unit. We're going to be factoring the polynomials now. So it's going to be kind of just the opposite of what we did. The first thing we're going to look at is what's called factors and the greatest common factor, or GCFS, if you guys remember that. Okay, so the first thing we need to know is what's a prime number. Now this is my own kind of definition for it. But a prime number is a number that is only divisible by 1 in itself. So some examples of that would be 2 is a prime number because only 1 and 2. 3 is prime, 1 and 3. 5, 7, 9. Now if I go a little bigger, we can go 17. 19. Okay, now some what I'm going to call non-examples. Okay, or these are what's considered your composite numbers, and we will look into that later on with some other things. And composite numbers are something that has more than 2 factors. So it's one that it's not just 1 in itself, it has something else. First one we're going to come across if we go through the numbers is you got 4. Because you got 1, 2, and 4. Okay, 6, because you got 1, 2, 3, and of course 6. And we'll go one more for an 8. So these are your non-examples. Okay. Way back when, you guys probably remember doing some prime factoring. Okay, where you tried to break down a number into just prime numbers. Okay. So let's take a look at 30. We'll deal with 30 first, and then we'll go over to 84. Okay. One way to do it is what's called a prime factoring tree, where you just branch off and you think of, okay, well, what times what will give me 30? Because 30 obviously is a composite number. And the first thing that comes to my mind is I've got a 6 and a 5. Okay. I know 6... because I have it up here as a non-example, so it's a composite, so I could break it down further. Whereas 5, I have listed as a prime number. So what I'm going to do is I'm going to circle it because I know that's a prime number. Okay, I can't break it down any further other than 1 and 5. We don't need to do that. It's good enough there. Now I look and I see 6, and I say, okay, what times what will give me 6? And, 2 and 3 will. Okay, and both of those are prime numbers. Okay, so now I've got them all broken down, and what you do next is you write them out then. So what you do is you say that it's 2 times 3 times 5 is your prime factoring tree. Okay, so that one's already been broken down. Now let's look at 84. Another way of doing this that people will do is they will do, and I kind of look at it as an opposite division. Okay, when we normally do division, we write the 84 and your sign looks like this. When you do this prime factoring division, you write yours upside down and you start dividing it by your prime numbers. Since I see this as even, I know I can divide it by a 2, so I'm going to divide this by a 2. Okay, and I divide 2 into 84. And I know that 2 divided by 84, when I work it out, is 42. Okay, still not a prime number, where our goal is to get it just with prime numbers. Now, 2 is a prime number. I like to circle it. So once again, we're going to put another division bar. And again, I know 2 is going to go into here because I have an even number and a 2. So I'm going to divide it by 2. Once again, I'm going to circle it because I know it's prime. And 2 divided into there goes to 21. Okay, 21 still is not a prime number because I think of 3 and 7 going in there. Either is prime, but I'm going to go ahead and write 3 in here. So there's 3. So divide 3 into 21, and that'll give me 7, which is also a prime number. Okay, so now I'm broken it down all into prime numbers. So one way you could write this out, so just start writing out, it's 2 times 2 times 3 times 7. Okay, and kind of go back to our exponents unit, I have 2 2's, don't I? So I could write it as 2 to the power of 2 times 3 times 7. And that's your best answer. Okay. You might have also noticed when I wrote these, they were both written from least to greatest. That is the way you should write them. Okay. All right. So let's take a look at when we got to find it for a pair. Okay. And you guys have had to do this, unfortunately, with fractions, and I know you don't like that. Okay. So what you first need to do is I got to find the GCF, or the greatest common factor, of this pair of 15 and 20. Okay. So what you do is you try to find out all the factors, okay, of that number. And what I like to do is like kind of go underneath each one and make a table. Okay. So I've got 15, so I know 1 and 15. Then I think 2 will go in. 2 doesn't go in. Okay, so 3. So 3 and 5 make 15. So 3 times 5 is 15. 4, 5. So there is no more. So the factors of 15, and I'm going to list them, go 1, and I'll put them in order. 1, 3, 5, then 15. Okay. Now I'm going to do the same thing for 20. Okay. I know that 1 and 20 work. Okay. Then I think, okay, I know 2 will go in there. So 2 and 10. 3 doesn't. Oh, but 4 does. So 4 times 5. Okay. So there is all the factors for 20. I'm going to go ahead and list them least to greatest. So least starting here, and it kind of goes around. So it goes 1, 2, 4, 5, then 10 and 20. Okay, so now to find out what the greatest common, remember, common, something that they both have. Okay, yes, they both have a 1, but we want the greatest. Okay, we want it to be the biggest. We want it to be the largest. Okay, so start at the end. Okay, he has a 20, but that one doesn't. So no. Then I see I have a 10. No, so 15 won't work. So the greatest common factor for this pair is a 5. Okay? Remember, start at the largest because you want to eliminate them, and it's common. Okay? All right, so let's take a look at one more. We're going to look at finding the GCF, of 16 and 18. Now, once again, I'm going to list the factors. And, of course, you guys, you don't have to do it this way. Just teaching to kind of show you. So I know it's 1 and 16, 2 and 8. 3 doesn't go in, but, 4 does. And it's 4 times 4. Now, here's the thing. If I have a factor of 4 written down, I don't need it twice. So I'm going to cross out 1. Okay, so I'm going to list for 16. It's 1, 2, 4. Then I'm going to go this way because I'm going from least to greatest. 6, 8, and 16. I'm hoping I didn't miss somebody. Okay, so once again, we're going to list them for 18. We know 1 and 18. Whoops. I know 2 goes in there 9 times. 3 goes in there 6. 4 doesn't. 5, and then I'm back to 6. Okay, so there's the factors of 18. Once again, I'm going to list them up here. Start at the top and go around. You're almost making a U when you do this. So 1, 2, 3, 6, 9, I'm running out of room, 18. Okay, now remember, we're going from the biggest to the smallest. So I'm going to start here. 18, nope. 16, no. How about 9? Nope. 8, nope. 6, 4, nope. 3. Their largest before these two is 2. And that doesn't seem large, but that's what it is. The greatest common factor for 16 and 18 is just 2. Okay? All right. There will be times, guys, unfortunately, where you're going to be working with 3. So let's look at a group of 3. Okay? Now, sometimes you guys can just straight out list them and kind of figure it out looking at them. Okay? Sometimes you got to go through and list them all. So like for 15, and you can even try listing them straight out. Sometimes I mess up a little bit and get them out of order. But I'm going to go ahead and try for 15. For 15, it's 1. And you can even go back this way. I'll go here. 15. The next one, 2 doesn't. I'm going to go 3. And 3 times, 5. I think I had that one before, didn't we? So those are our factor. Yeah, they're a little spread out. Okay, but that's all right. But 1, 3, 5, 15 are all the factors of 15. Now I'm going to go 30. I know 1 and 30 will work. Okay. 2 works, of course, because there's 15. So there's a greatest common factor. Now, if I look at this and I say 40, because I'm going to go ahead and say 1 and 40. 15 is not a factor of 40, is it? So I can say, nope, that ain't going to work. We know 30 and 40 can't work because can't go there. So we could just kind of forget some of these down here and start working lower. I know 2 works and 20. Let's see, 3 doesn't work. 4 will work, that's 4 and 10. But I also know 3 and 10 will work here, but I obviously can't work here. So I'm going to say 5s, because 5 times 3, 5 times 6 works here, and 5 times 8 works here. Okay, so your greatest common factor for 15, 30, and 40 is 5. Sometimes it's easier if you go to the bigger number first. Okay, so give that a try. Okay, now the last thing you guys might see, or no, you're going to see, okay, is finding the greatest common factor for ones like this. Okay, so what you're going to do is you're going to look at the number separately, okay, and then the variable. And of course, we're going to be looking at exponents, guys, so that's going to play in here, okay? Likely we only have 1 here, okay? So I already know the greatest common factor for 4a and 10a is going to have an a in it. So I'm just going to cross that out. Now we just got to figure out for the 4 and the 10. I'm going to work with the bigger number first. Okay, so 10's factors are 1 and 10. Then I know 2 goes in, and also 5. Okay, and I think we can look at this and we can all say, for 4, we know it's got 1, 2, and 4. So their greatest common factor is 2. Okay, so to completely write this, it would be 2. A is the greatest common factor for these 2. Okay, let's take a look at one more like this, and then I'm going to show you something off the assignment you have to go with this. Okay, now I have 15x to the third and 21x to the second. Okay, I'm going to leave the numbers alone for first off because I think you guys will be okay with that. But we got these x to the thirds and x to the seconds. So I'm going to write the numbers here. Here's the 15. Here's the 21. Okay, and then I'm going to go ahead and I've got an x to the third here and an x to the second here. Okay, but what does this mean? X to the third power. That means x times x times x. So that one has 3 of them. Down here, we have 2. So how many do they have in common? You can kind of circle them. There's 1 pair. There's 2 pairs. So I can pull out 2 x's. So the greatest common factor for just the variables is x squared. Okay, now let's look at our numbers. I'm going to go 21 first. Okay, 1 and 21. 2 doesn't go in. The next factor I know is 3, and that's 3 times 7. 4 doesn't go in. 5 doesn't go in. 6. So these are all that factors. Okay, so for 15, I think we already know what it is, but let's figure it out anyway. We know 1 and 15. 2 doesn't go in. Oh, but 3 does. And that would be 3 times 5. 4 doesn't go in. 5 does, but I already have it right there. So the greatest common factor for the numbers of 15 and 21 is 3. So the greatest common factors, now this is where you put it all back together, would be 3x squared. So that is that greatest common factor. Okay. All right. For you guys